So the next thing that's worth noting here is that while the ball, when you hit play, does fly off in a straight line, it doesn't do a particularly great job of really adhering to the surface. Now, there's a couple of ways we could accomplish this. A lot of people would jump to the conclusion that it would be a good idea to set the mass scale up and force it to be a heavier object. There's a couple of ways to do that, but because we're making a game, I kind of don't want to deal with it as far as mass goes, because that can have some other ramifications that just could be problematic. I'll give you an example of what I'm talking about here. So I'm just going to place these, and if I hit play, when it shoots off, you can now see it kind of does that, which isn't really what we want. Instead, what I would like is to set it up so that the ball, it at all times looks down at the surface that it's on, and it tries to stick to that surface and adhere to it as best as it can. So I'll show you how to actually do that. The first thing that I'm going to do is I'm going to go into my ball again, so I'm in my event graph, and I'm going to go ahead and I'm going to do that very first step, which was I had to check what was beneath the ball itself. And the way to do that is what's called a line trace. So in this case, I'm going to do a line trace by channel. We put it over here, and all a line trace by channel does is we've got a start position and an end position, and if it hits something between those two positions, it's going to return a value for me to inspect it more closely and get information from it. Now in this instance, the things that I need are rather simple. I need to start this line check from my own position, so this actor's position. So I'm going to type in get actor location, and you can see we've got this thing here that says get actor location. If I click on that, that now gives me a node that gets the actor's location. So that gets the ball's location in world space. Now you can see that we need to trace to a location, and I need to trace downwards. Now within Unreal, X is forwards, Y is sideways, and Z is up and down. So what I actually need to do is get my current location and subtract, say, 500 units from it, and then trace to that location. So all I need to do here is subtract. See here, it now says this number, subtract 500, is going to be my end position. And if I want to preview that, I can actually set the draw debug lines up. So if I type in persistent and hit play, you'll see what I'm talking about. See those lines coming out beneath it? Those are all of the checks. And you can see that along the way, it's left these to say exactly where the surface was that it was hitting. Now that we have information about what's beneath us, let's use it. So to do that, I need to go ahead and look at the hit result. So see this thing here that says out hit? I'm going to drag off of that, and I'm going to type in the word break. I'm going to break the hit result, and you can now see that when we collide with the ground, I'm able to now get all of this information. And in this instance, all I really want to do is, once again, in the same way that I added an impulse, I'm going to click on this, and I'm going to hit Control W to duplicate it. I could type in just the word add impulse, but you'll find that there's a lot of copying and pasting going on with Blueprint, so it's good to get into the habits. So I'm going to get this, and I'm going to tell the line trace to add an impulse. The next thing I'm going to do is, unlike before, where this was connected to ball, I didn't copy the ball reference. So I'm going to make sure I drop that in again. So I'm going to go up to the top here, select ball, and drag it in. I'm then going to connect that to the target so that the thing that we're adding an impulse to is the ball. I'm now going to go ahead and I'm going to get the impact normal of hit test, and we're going to multiply it by -1. Essentially, the impact normal is the direction in world space of the trace test. So by getting that and then multiplying that against an arbitrarily large number that we can use, I'm going to multiply it by a float. Before, we created a variable for the default speed. I'm going to go ahead and create a variable again, and this one's just going to be called table stickiness. I'm going to set that to be a float. I have to compile it to get it to appear, so I've compiled it. I'm now going to type in, say, let's make it super sticky to start with. Let's see what happens. I'm going to set it to 5,000. And in the same way before that I multiplied this number against delta, I'm once again going to get this. So the stickiness, I just dragged it in. float by float. I'm going to multiply it against delta again. This is rather ugly, so I'm going to double click on the line to add a reroute node. Now I got this set up. I'm going to multiply that against my impact normal, which means get the direction of the line trace and try and stick yourself in that direction. I'm going to hit compile, save, and you can now see that it immediately stuck down. In fact, it's doing such a good job of sticking down that it can't even make it over things like this. But that's okay. So that's going to be a number that we're going to tweak a bit as we go on and, develop the project. 5,000 is probably a good enough starting number, because if I was to add this and this, you can now see that we've got something that correctly kind of sticks around until there's no more surface to stick to. Because once there's no more surface to stick to, it's no longer trying to put a negative value to itself. It's no longer trying to shoot itself downwards. Okay, so with that, we've now got basically almost everything we would be really using for the ball. So I'm going to save it. And we're now going to move on to looking at some more gameplay related things. So we've got ourselves a moving pinball, but it would be a good idea for us to actually have some sort of environment going on that we could test with. So it's at this stage that I'm going to delete everything that's there. I'm going to drag in a box. I'm going to set the box's location to be 0, 0, 0. And I'm going to set it to be 3600 by 2600. Oops, sorry. On the x-axis, 2600. So I have an environment that looks like this at the moment. The next thing I'm going to do is I'm going to drag in another box. And again, I'm going to set it to 0, 0, 0. But this time around, I'm going to change the dimensions just a little bit. And this is going to be 3400. Sorry, 2400. And this will be 3400. You'll notice that it's just on the inside of the box here. I'm going to change this from additive to subtractive so that we have ourselves some nice walls. And then I'm going to set the Z to be... Actually, I'm not even going to set it on the Z on that one. I'm going to click on the outside box. I'm going to go to geometry mode, which is this button just up here. I'm going to click on the bottom, and I'm going to set my snap grid to 100, and I'm just going to bring this down just one square. So we've now got a basic environment, and it would be a good idea for us to start getting an idea of how our camera should be functioning. So for a quick, I feel like this just needs to be noted just in case anyone's familiar with Unreal and they're unsure as to why I'm taking this approach. Normally within Unreal, when you have a player character, you actually have two aspects to any character in the world. You've got a controller and then you've got the pawn. Now, the controller refers to kind of the brain of the object. So in the context of a player, the controller is going to be the thing that handles all of the inputs, whereas the pawn is kind of like the body. So the controller sends messages to the pawn, and the pawn knows what to do. Now, in this situation, I'm actually not going to have a player pawn, because it's simply not necessary in a pinball game. Instead, what I'm going to do is I'm going to go up to my modes panel, and I'm going to type in the word camera. I'm going to drag the camera into the world, and I'm going to set it as 0 on the x-axis. I'm going to drag it up. And I'm going to go ahead and just rotate it around 90 degrees. I'm going to look down at our pinball map. So we have something like that happening. Position it as best as I can for the time being. And then if I scroll down here, you'll see that there's an option that says Auto Activate for Player. And I'm just going to set that to be Player 0. And now, when I hit play, you'll notice that the camera automatically snaps to this location. In addition to this, I no longer have the piloting controls that I had when I hit play earlier. So with this setup, I'm now going to go about actually creating some more things within this world. I think it would be a good idea for us to start moving on to bumpers.